All right. Inscribed angles. So I'm going to have an angle inside of a circle, right? So I want to talk a little bit about definitions because that really will help you. So inscribed angle, an angle whose vertex is on the circle and sides contain secants of the circle. So it could be, well, a secant goes like the line could go all the way through a chord, you know, like this is more of a chord because it starts and stops, but this could be, this section is a chord, but then the line goes on. So an intercepted arc. So I'm going to have an arc of a circle and it could be intercepted by this, these two lines. So I just have like this section, and then I have this section, and then I have this section. So I have three parts now to my circle, three arcs to my circle. An inscribed angle, inscribed means that there's a shape inside a circle. Circumscribed, on the other hand, is a circle with an inscribed polygon. So inscribed and circumscribed. Now I'm going to compare them with the sentence because they're very similar sentences. Okay. So I could say that a polygon is inscribed in the circle. It could be a triangle, it could be a quadrilateral. I could put a pentagon inside of a circle, whatever fits. But remember, the shape, each corner of my polygon has to touch the edge of the circle. An octagon could fit inside of a circle. So the polygon is inscribed in the circle, and the circle, let me move out of the way, is circumscribed about the polygon. A polygon is inscribed in the circle, and the circle is circumscribed around the polygon. So the circle is around the polygon, and the polygon is inside the circle. It means the same thing. It's all pretty easy to. Okay, let's do I'll have to erase that sentence. All right. Okay, I'm going to have you label C and D because we're going to talk about C and D. Theorem. If two inscribed angles of a circle intercept the same arc, so two inside angles, inside, the angles are inside, and they intercept the same arc. So it's like angle C, this angle so this arc that we're talking about is right here. Ooh. So, like that, okay? then the two angles are congruent. Angle C and angle D are congruent. Angle C and angle D are congruent. Right? Seems pretty straightforward so far. All right, let's start doing some practice. So read this theorem right here. Measure of an inscribed angle. That's important. If an angle is inside a circle, remember the angle vertex has to touch the edge of the circle. So you will always have this angle vertex touching the side of the circle. Its measure, the measure of the angle is half of the arc. So arc SQ, if the angle, so the angle is the smaller of the two choices, the arc is bigger. So the angle is going to be my small number, and my arc is double the angle. Okay? SQ, this is 60. What's my arc? SQ?
120.
120. The inscribed angle is 115. My arc, huge arc, by the way. Z, go in order, Z, W, X. Start from Z, go to W to X. Z, W, X is what?
230.
Double 115. So 2 times 115. 230. Good. Okay. Ooh, the arc is 100. Arc is 100. So, how big is the angle?
50 degrees.
50 degrees. Good. This seems pretty easy, right? Like, totally straightforward. Okay, moving on. Okay, number 4, quadrilateral. Now, I want to know how big this arc is here. I'm not told anything about this side or this side. I'm only told about a 64 and an 84. So this blue arc, you know, the whole thing makes 360. How am I going to figure out what the blue arc is? If you guys want, grab a calculator again. What am I going to do if I know the whole circle is 360, but I only care about this blue portion?
Would you add up 84 and 64 and subtract it by 360?
Yes. So you guys have calculators. So together, the 64 and 84, they make 148. So 360 minus 148. I don't have a calculator. So
212.
212? Okay, so blue arc is 212, which means X is going to be half of 212. right? 106, 106. So you're given partial information sometimes. Okay, so all of this 1, 2, 3, 4 falls under the theorem where the inscribed angle is half of the arc, right? So now I'm going to do a new theorem and we'll finish off. Yeah, 5 and 6. Okay. The theorem says, if I have this shape, there's a chord, there's a tangent line, AED, this angle here, is half of the arc, ABE. So, very similar. The inside angle is smaller than the arc. AED, the angle, is half the size of the arc. So that means that the arc is bigger, the angle is smaller. That's exactly what we were doing earlier. Okay. Number 5. 210 degrees is the arc here. This arc. That arc is 210 degrees. And I then want to know this angle that's inscribed in the circle. So following this, the arc is bigger, arc is greater than the angle, right? Okay, what are we going to say for angle 1?
Would it be 105 degrees?
It would be half of 210. Very good. All right, now I'm given an angle. Remember, the angle is the smaller of the two. The angle is 45, and I want to know this arc. Oh, I don't. I want to know ABC. AB, ooh. First of all, hold on. AC, let's talk about what that is. If this angle is 45, how big is just AC?
90.
Yep, double. So that means that I have 90 degrees already spoken for in my circle. This is really easy because the whole thing is 360, 90 is already used up. ABC is coming from this orange, from that. So, what is it?
270.
270 degrees. And if you're not sure, just in case, it's just because we did the whole circle, take away 90. That's where we got the 270. This is easy so far, yeah? Today's a pretty nice mellow day. Are you guys finished copying those notes? Can I go scroll down? I'm like staring at the camera like, because they're there.
Yeah, you're good.
Okay. Okay, last bit, algebra. We've got some algebra going on here. Let me clean this up. Okay, so a quadrilateral can be inscribed in a circle. So this four-sided can be in the circle if and only if, which I'm not sure if you've known, but IFF is an abbreviation for if and only if in math, maybe in science too. Its opposite angles are supplementary. Supplementary, 180 degrees. Opposite angles. Angle E plus angle G equals 180. Angle F plus angle D equals 180. Okay, opposite angles, supplementary, 180 degrees. So, 7. $115 means that its opposite angle x have to be 180, right? So do that on your calculators, tell me what you get. Say it again.
65.
65, you are correct. So that's angle x. So I'll write that in. Okay. These y values are the same size. They're the same size angle. So algebraically, you can punch the numbers into your calculator and figure out, but algebraically it's going to be 115 plus 65 plus 2 of the y's equal 360. But I think that an easier way to do this would be to say the quadrilateral has 360 degrees. 115 is taken up. 65 is taken up. Subtract those. You would do that anyways. And then whatever you get, what do you get when you subtract those? $360 minus 115 minus 65.
Y equals 90.
Y, 2y, let me go slower. So the two y's together have 180 degrees and they're the same size. That's where you get the y equals 90. 90, 90. 90, 90. Okay, lastly, go ahead and try 8 on your own. Opposite angles add up to 180. So y is the first one you should solve. Y and z are both pretty easy to solve for. Okay. Give me some numbers. Give me some numbers here.
Y equals 60 degrees.
So 120 plus 60. Yeah. Someone else? Z equals, in here, ladies? 100 degrees. 100 degrees. Okay? So, perfect. All right. What I'm going to do, I'm not going to give you homework on Pearson. I'm going to give you homework from this old book that I like. I'll post. So let me stop recording. So we're going to practice this.